and it's me, Priska Joseph. We already uploaded some revision classes in this series. If you have to watch all those classes, and today in this class we are discussing PYQ 2023. Before starting our class, if you are watching my channel, please subscribe it and don't forget to like and for the notifications. And I am waiting for your comments, so please comment below. So let's start. And the question is, the ratio of HCF to LCM of the least composite number and the least prime number is what? This is the question. So, ratio of HCF to LCM of the least composite number and least prime number. Okay. So we have to find out the ratio of HCF and LCF of two numbers. Which are they? First one is least composite number and least prime number. So what is the least composite number? What is it? It is 4. Okay. One is a prime number? No, one is neither prime nor composite. Okay. So what about 2? 2 is the least prime number. Okay. So least prime number, which is 2. Okay. So 2 is the prime number. Is 3 is a prime number or composite number? 3 is also a prime number. Okay. And 4 is the least composite number. Okay. So these are two numbers and we have to find out HCM and LCM of these two numbers. Okay. Values of 2 is equal to 2 itself. What about 4? It is 1, 2, 2. Or 2 square is the factors of 4. So HCF is equal to 2 and LCM is equal to, what is it? 4. Okay. So HCF is 2, LCM is 4. Then we have to find out the ratio between HCF and LCM. What is it? 2 upon 4, which is equal to 1 upon 2. Okay. Or 1 is to 2. Okay. So option A is the right answer. 1 is to 2 is the right answer of this question. Okay. Clear? Move on to the next question. So dear children, there is an interesting question for you. It is, find the least number which when divided by 12, 16 and 24 leaves the remainder 7 in each case. Okay, find the least number which when divided by 12, 16 and 24 leaves the remainder 7 in each case. So dear children, what to do is, so if you are given by such a question, don't worry, we have to find out the LCM of these numbers. Okay, so what is the LCM of 12, 16 and 24? What is that? Okay, what is the factors of 12? It's 3 into 2 square. Okay, what about 16? It is 2 to the power 4. Okay, yeah. 16. Then power 3 into 3. So this is the factors of 24. And what is LCM? The highest powers of each factors. Okay. So in this case 2 to the power 4 into 3. Okay. Any other factors? No. Okay. So 2 to the power 4 is 16. 16 times 3 is 48. Okay. So we divide the number with the 12, 16 and 24. We get a remainder 7. Don't forget to consider this 7. So our answer will be this 48. That is LCM plus remainder. Okay. LCM plus remainder is the answer. So LCM is 48. Then what about remainder? Remainder is 7. That is 48 plus 7, which is equal to 55. So the answer is 55. Okay. So this is a simple one. And let's solve question number 3. So now the third question is, two numbers are in the ratio 2:3 and their LCM is 180. What is the HCF of these numbers? So this is the question. That is, the ratio of two numbers are given and their LCM is 180 and we have to find out the value of HCF. Okay, so this is a question. So let the numbers be 2x and 3x. We are given by the ratio, we have to take the numbers as 2x and 3x. Okay, then HCF. What is HCF? HCF of 2x comma 3x is equal to, what is it? It is x. Okay, highest common factor, and we can take x as the highest common factor, that is HCF. Okay, then by the relation, product of HCF and LCM is equal to product of two numbers. Okay, what is it? HCF, we don't know. HCF is x into LCM is 180, which is equal to 6x square. Okay, let's cancel this x here. Then 180 is equal to 6x. Then x is equal to 180 upon 6, which is equal to 30. Okay, so 30 is the answer. This is very simple one. So let's move on to the next question. So now the fourth question is, prove that root 3 is an irrational. Okay, root 3 is an irrational. We have to prove it. Okay. So, dear children, you have to practice this question very well because this is a short question. Okay, so let's start. That is, we have to take root 3 is equal to a by b, where a and b are co-primes. Okay, what is co-primes? Numbers which have common factor 1. No other common factors in between. There is only one single common factor, that is 1. Okay, so this a by b is a root 3 is equal to a by b, where a and b are co-primes. Then next step, root 3 into b. Root 3 into b is equal to a. Okay, then squaring both sides, we get 3b square is equal to a square. Okay, if 3 divides a square, then 3 divides a. Okay, by theorem 1. Okay, we take a is equal to 3c, where c is an integer. Where c is an integer. Okay. Again, squaring on both sides, we get a square is equal to 9c square. Okay. Substitute this value in this equation. We get 3b square is equal to 9c square. Okay. By using this relation, we can write 3b square is equal to 9c square. Okay. Then if 3 divides b square, then also 3 can divide with b. Okay, by theorem 1, which we discussed in the first class. Okay, so from these two relations, it is clear that a and b are not co-primes. Okay, first our assumption was a and b are co-primes. Then from this relation, it is clear that a and b are not co-primes. Okay, this contradicts the fact that first we assumed that root 3 is a rational number. Okay, I forgot to write here. That is, first assumption was root 3 is a rational number. Okay. Then we take a by b as co-primes, and from all this relation, it is clear that a and b are not co-prime. So we conclude that our our assumption that is root 3 is a rational was a contradiction fact. So we can conclude that root 3 is a irrational number. Okay, we can conclude that root 3 is a irrational number. Okay, hope it is clear for you. Actually, this is very simple. First, we have to take the contradiction statement, that is root 3 is a rational number. Then root 3 is equal to a by b, where a and b are co-primes. And by rearranging this equation, we can say that if 3 divides a square by theorem 1, if 3 divides a square, then 3 also divides with a. Okay, so a is equal to 3c, where c is an integer. We have another constant term, that is c. It's an integer. Then a is equal to 3c. Then squaring both sides, we get a square is equal to 9c square. And substituting the value in here, we get 3b square is equal to 9c square. Then as we did earlier, 3 divides b square, then 3 divides b by theorem 1. Okay. From all this, from these two statements, it is clear that a and b are not co-primes, and hence our statement was wrong, or hence our assumption was wrong. That is, root 3 is not a rational, it is clearly an irrational number. Okay, so practice this question very well. So let's move on to the next question.